My name is Parchment, and welcome to my presentation on GATE for Natural Language Processing. Let's first talk about GATE. GATE abbreviation is General Architecture for Text Engineering, and GATE happened as a result of a multi-million research and development in 1995, and is funded by commercial users and others like the EC, BBSRC, AHRC, and JISC. It is a natural language processing toolkit written in Java, and it has a main application named Annie, which we'll discuss later. It has text processability and it do process tasks for cancer and drug research, web mining, information extraction, and recruitment. Its main users are scientists, company, businesses, and educators. GATE and scientists. Scientists benefit from GATE through repeatability, quantitative evaluation, collaboration, and reusability. And it's relevant to scientists because of its computational linguistics, natural language processing, and language engineering. GATE and educators. GATE provides students starting point for projects because of information extraction features, and it's used by mostly PhD students, and it's available in diverse locations like Bulgaria, Copenhagen, and Surrey. GATE and businesses. It provides service for business in a diverse location, which I mentioned like Surrey, but it also includes places like Connecticut, which is in the United States, and Chengdu, Sichuan in China. And for businesses, it can be a free open software, or if businesses are known to use GATE, they can go to enterprise packages, which offer 24/7 customer support, on-site training, and bespoke development. Okay, businesses choose GATE because of their comprehensiveness, their scalability, openness, extensibility, and reusability, just like as scientists, transparency, robustness, and sustainable efficiencies. There are many GATE products, and they are the GATE Developer, GATE Embedded, GATE Teamware, GATE Memoir, GATE Wiki, GATE Cloud, GATE Process, and also they call it the GATE family. The GATE Developer is, as you see picture here on the left, is an integrated development environment for language processing components with a widely used information extraction system and a set of other plugins. The GATE Embedded, picture right, gives access to all the services by GATE Developer and more. You see the GATE Embedded, it has the XML document format, HTML document format, PDF document format, a document format layer, some corpus, some annotation, the feature map, some gazeters, which we'll discuss, and the Annie, which I'll talk about earlier. The GATE Teamware. It provides an environment for high-volume factory-style semantic annotation project built around a workflow engine and the GATE Cloud backend web services. The GATE Memoir stands for Multi-Paradigm Information Management Index and Repository. It supports ONTO Text KIM and is built on ONTO Text Semantic Repository Family, GATE Annotation Structure Database, plus full text indexing from MG4J. Now, GATE Wiki. It's a controllable wiki and CMS collaborative and asynchronous offline editing, hosting control languages for round-trip ontology engineering. The GATE Cloud, picture here on the right, picture's a little foggy, but it's a parallel distributed processing which combines the GATE Embedded, which we discussed earlier, with an optimized service infrastructure running on supercomputer hardware. The GATE process. Through that process, you learn how to commission, design, develop, implement, and maintain sustainable text workflows. There's some other GATE family, and for businesses, it does include into 1 week of web training, and after that 1 week, you can become GATE certified. Okay, remember I told that GATE has an application called Annie. Annie is abbreviated for a nearly new information extraction system. Annie is a ready-to-run information extraction system made from statistical NLP components. It includes a sentence splitter, tokenizer, part-of-speech tagger, a name entity recognizer, a gazeter, and a co-reference tagger. Here we'll see the ANI architecture, and you see it has the document format like mentioned XML, HTML, SGML, and email. It takes an input which a URL text and into a gate document, and Unicode tokenize it. It can also let me master it, the Gazebo lookup, the sentence splitter, and the hip hop tagger. Then from the tagger, you can go to semantic tagger, the name matcher, the bootstrap parser, the this into that, and the output it will be a gate document, a XML dump of NETETRST annotations. Like I told you, the features which are tokenizer. The tokenizer, the sentence splitter, split up sentence and it split annotations. The Gazebo is used to look up annotations. The PO tagger, it adds category features to token annotations, and the JAPE recognizer do date, person, location, organization, money, and percent annotations. The auto matcher add match features to the any annotations. Here we see the sentence splitter, and you see that it split up the sentence into brackets, kind of similar to what we learned in Python and Weka. Like there's a sentence right here. The document with tokens. The first line, as you see, is Union appeals for talks to NBA strike. And as you can see down at the bottom where it has a token and it categorize it of NNP, and the kind is word, the length is 5, ortho is the upper initial for the U, and the string for string union. For appeals, we know the length is 7, and it doesn't really have it. It has an upper initial also with the A. Let me see this. I can't give you the one that has lowercase. Now the Gazebo editor, you will see the definition of file entries and the entries for selected lists. Like this is an airport list, and it's showing you the city, and we see Alka, Ababa, Abidbaj, Abu Daba. Example of using gate and ANI. For this, we're using a 3-stage procedure using the tokenizer, Gazebo, and the name entity grammar. We wish to recognize the phrase 800,000 US dollars as an entity of type number with the feature money. First, give an example of a grammar rule and corresponding macros for money, which will recognize this type of pattern. The macro for recognizing million billion. The macro will be macro billion with a token string is M, and token string million, token string with B, which stand for billion. The macro for recognizing amount is that amount number for token that kind is equal to number. Token that string has the comma, which will represent the amount. The token that string also is equal to the point, which will recognize the decimal symbol 0.00. And also there's a for space in between the 800 and also in this example they define a grammar rule, and then rule 1, which is money, example 30 pounds is amount number. And also for lookup, it will look up major type will be equal to the currency unit, and the money, that number will be equal to kind equal money, and rule is equal to money 1. So step 1 is tokenization, looking for 800,000 US dollars. The tokenizer separates the given phrase into the following tokens: a word, a number, a punctuation, and space token. Token with the string equal 800, the kind is number, and the length is 3. Token string with a length of 1. Token string 000 is a number with a length of 3. Space token string another comma is a space and the length is 1. Token string US is a word, the length is 2, and its author is all caps. String another space and its length is 1. And string dollars is a word with a length of 7 and it's lowercase. Step 2 will be to use the list of lookup, where you use the Gazebo, where lists are then searched to find all occurrences of matching words in the text. It finds the following match for the string US dollars. It look up in the minor type unit. Step 3 will be the grammar rules 1. The grammar rule for money is invoked. The macro million billion is passed through since the given phrase containing none of the specified string. The macro amount number recognizes the given phrase as a number, followed by a sequence of the form, comma plus number, and then followed by a space. Then the rule money one is invoked, which recognizes a string identified by the macro amount number, followed by an optional space, followed by a unit of currency. Grammar rules 2. In our case, US dollars will be recognized as a currency unit, so the rule money one recognizes the entire string 800,000 US dollars, and it will be annotated as number entity of type money, and the result will be number kind equal money and rule equal money one, which means we have our match of finding 800,000 US dollars. We have finished this presentation. Thank you for watching this presentation, and I hope you enjoy it.